So for today's class, we'll see about the working of a four-stroke diesel engine. In the previous class, we had seen the working of a four-stroke petrol engine. Okay, so today we'll see about the working of a four-stroke diesel engine. So here, what we are able to see is a uh, multi-cylinder engine. So here we have piston number 1, 2, 3, and 4. So it's a multi-cylinder engine. So generally present in cars, trucks, and so on. Okay. So here we have the piston, here the connecting rod, and this is the crank, the dark gray region, and this is the crankshaft. And above this, present in the cylinder head, we have the inlet and outlet valves. Okay, so just to refresh, we'll see about the working of the engine in common. So every time the piston slides inside the cylinder, this linear movement of the piston is being converted into rotatory motion, which is being tapped at the crankshaft. Okay, so this circular motion is being connected to the other end, either to the driver's end for a wheel or for any other purpose. So there's a piston connecting rod connected crank. So big end to be of the connecting rod to be connected at the crankshaft. So as the piston moves, we can clearly see here the linear movement of the piston is going to be converted into the rotatory motion, which is also called as the slider crank mechanism, right? So whether it is a four-stroke engine or a two-stroke engine, four-stroke petrol or diesel, it's going to work on the same principle. I mean the mechanism. Okay, so all this thing is going to be housed inside the piston connecting rod into the engine block, and the crankshaft and the crank will be housed in the lower base of the engine body, that is called as the crankcase. We can generally see uh, even now also in the automobiles there will be a round dome shaped below the engine. So that is nothing but the crankcase, inside which there is the crankshaft and the big end bearing to be connected, right? And above this is this piece of block which is called as the engine head. So this will be placed over here above the engine, which will usually carry the inlet and outlet valves. And apart from that, if it is a petrol engine, there will be a provision for spark plug. If it is a diesel engine, it will have a provision for diesel fuel injector. No, but there is no spark plug in a diesel uh, engine. Right. So yes. So here we can see that there is an inlet valve. So inlet valve and an outlet valve, and this one is the fuel injector. Right. So what happens in this case, since it is a four-stroke diesel engine, the first stroke is going to be the suction stroke only, through which what is going to happen, the piston is going to move from TDC to BDC. Okay, so it is going to slide down towards the crank end. So during this time, the inlet valve will be open. So thereby what is going to happen, there is a low pressure region created in this piston cylinder arrangement, and the inlet valve is also open. Thereby what is going to happen, the air is going to be drawn in through the inlet valve. So please remember, in a diesel engine during the suction stroke, only air will be drawn in. No fuel will be coming inside the into the piston cylinder arrangement during the suction stroke. Only air. 100% it is going to draw only the air, no fuel at all in four-stroke diesel engine. Right? So during this time, what happens as the piston moves from TDC to BDC, it is going to draw the air inside the piston cylinder arrangement through the inlet valve, and as the piston is moving towards the BDC, the crank is going to go for a half a rotation. Yes. So once it reaches the BDC, the inlet valve is going to be closed, outlet valve is already closed. So the piston starts to move from BDC to TDC, that is from the crank end to the cylinder head. So what is going to happen? Inside this arrangement, now we had only air that was filled in, which is now going to be compressed because the volume is going to decrease as the piston moves towards the TDC. So we can see that all this air space, the space that was occupied by air is now only compressed only for such a small volume. So thereby what has happened, since the volume has decreased, the pressure of the air and temperature of the air is going to be increasing. So because why is this happening? Because we are going to compress the air. We already know that air is all gases are compressible, right? So since this air is being compressed, its pressure and temperature are going to increase. So in this region, when the piston is at the TDC, the air is compressed so much that it is at high pressure and higher temperature, right? So that is the end of the compression stroke now. So during this compression stroke, inlet valve and outlet valve both are closed. So the pressure will be about 40 bar of pressure and the temperature of the air will be around 550 degrees centigrade. So at the end of compression stroke, what is now going to happen? Through the fuel injector, the orange color diagram that is represented over here, we can see here a kind of inverted V shape with a light yellow color, nothing but the fuel, diesel fuel is being injected through a fine atomized spray, very fine spray of diesel is being injected. But when is it being injected? It is being injected where we have a high pressure air at higher temperature. So this high pressure air and temperature is more than enough for the combustion to take place, so that once the fuel is being introduced at this high pressure and temperature, it is undergoing, it is going to go combustion process, right? So fuel is being injected, combustion is going to take place. So because of this combustion, okay, so it will go around about 150 bar and raising its temperature up to 2500 degrees centigrade. So because of this combustion, because of that force exerted onto the piston, now the piston moves from TDC to BDC, which is taking place after the combustion. That is nothing but the power stroke. So during the power stroke also, both the inlet valve and outlet valve is going to be closed, right? So here till the power stroke, it is the third stroke that has been finished. So at the end of the power stroke, what is happening? The piston has reached the BDC. Now, once it has reached the BDC, the piston is now going to move towards the TDC due to inertia, right? So thereby what is now present over here is only the gases, burnt gases, right? All that gases are going to go out through the exhaust valve. So if we look here, so if we just have a look over here, as the piston is going to move towards the TDC, we'll be able to see that the outlet valve is open, inlet valve is closed. So all this burnt gases can go only through the outlet valve or the exhaust valve. So this piston is going to push all this burnt gases that is present inside the piston cylinder arrangement through the exhaust valve. So during this time, the piston is going to raise from BDC to TDC, and at the same time, the crank is going to go for another half a rotation, right? So this is the end of the fourth stroke or the exhaust stroke that is called. So it has completed one full cycle at this particular moment. Now all the burnt gases is being sent out. Now the piston is also at TDC. Now nothing is present inside the piston cylinder arrangement. Now to continue this cycle, the piston is going to move towards the BDC. So during this time, suction stroke is going to take place. So at that time, the inlet valve will be open and only air is going to be drawn in, and this cycle continues. So you can see here, first stroke, this is the compression stroke, combustion taking place, power stroke, and the exhaust stroke. So this cycle keeps on repeating, and this is how a four-stroke diesel works. Right. Okay. Yes. So this is what we require. Yeah. So during this time, after all these four strokes, so let us see along with the PV diagram for a four-stroke diesel engine. So for a four-stroke diesel engine, once again similar to a four-stroke petrol engine, we have to write the individual diagram for every stroke. So for the suction stroke, as usual, as represented for a four-stroke petrol engine, draw the diagram but the only change will be that instead of a spark plug, here it will be with a fuel injector. Here it will be with a fuel injector, right? Okay, so during the suction stroke, the piston is going to move towards the crank. Okay, that is from TDC to BDC. The crank is going to rotate for half a rotation, right? And during this time, air is going to be inlet valve is open, exhaust valve is closed. So over here in the compression stroke, as I have explained, inlet valve and outlet valve is going to be closed. Piston is going to move from BDC to TDC, compressing the air. So high pressure is going to be created. The crank is going to go for another half a rotation, right? So the next thing is that during the power stroke, at the end of the compression stroke, fuel is being injected because of the high pressure and temperature of the air that is present inside the piston cylinder arrangement. It is undergoing to go combustion. So because of the combustion force, the piston is going to move downwards. So the crank is going to go for another half a rotation. And during this time also, the inlet valve and outlet valve is closed. And finally, during the exhaust stroke, the piston is going to move from BDC to TDC. During this time, inlet valve is closed, exhaust valve is open, right? So as the piston is going to move from BDC to TDC, the volume is decreasing in the engine piston cylinder arrangement. So it is going to push out all these burnt gases out through the exhaust valve. And during this time, there is another half a rotation of the crank, right? So now let us see about these four strokes with respect to a PV diagram. How to represent this, the change in volume and pressure with by drawing a PV diagram. So coming over here, during the suction stroke, inlet valve is open, right? And the piston is going to go from TDC to BDC. So volume is going to increase, right? And since over here it has been connected where the inlet valve is open, okay, so there is no change in the pressure at all. So the piston, as it moves from TDC, that is from point A to BDC, it is at the volume is only going to change. There's an increase in the volume in the piston cylinder arrangement, but there is no change in the pressure. Next, what is going to happen in the compression stroke? Inlet valve is closed, outlet valve is closed. So that means it is like a confined cylinder, confined space. So the piston is going to move in the upward direction, that is from BDC to TDC, compressing the air that is present. So this pressure will increase. So at the same time, when is it increasing? It is increasing because the piston is moving. That means the volume present in the piston cylinder arrangement is decreasing. So it is going, the volume is going to decrease and pressure is also going to increase. So it is going to reach from point B to point C, right? That is when the piston moves from point B at BDC, point C at TDC, the volume is going to decrease. So pressure is also going to increase, volume is also going to increase. So the next thing is that what is going to happen at the end of the compression stroke, fuel is being injected. Okay, due to this, what is going to happen? Combustion is going to take place. Excuse me. So this will happen almost at constant volume because there is a slight movement of the piston for the power stroke by the end of combustion to take place. Because of this reason, theoretically speaking, the theoretically speaking, right? So theoretically speaking, the volume is going to change, but at almost uniform pressure. Why? Because at the same moment, the piston is also going to move and the combustion is also going to take place. So in a diesel engine, the combustion, theoretically speaking, it happens at constant pressure, right? Okay, so during this time, what is going to happen? This is the combustion process. So during this time, what is going to happen? From now, the power stroke starts where the piston starts to move from TDC to BDC. That means the volume is going to increase. So we can see here from D to E, the volume is going to increase. There is so much of change in the volume as the piston is going to go towards the crank end, right? At the same time, since the cylinder is going to be expanded, the volume is going to increase, pressure is also going to drop down, which is at point D, point E, where it reaches at the end of the power stroke at the point BDC, right? Now going to the fourth stroke, that is the exhaust stroke. Now during this time, what is going to happen? There is a sharp decrease in the pressure. This is because the outlet valve is open. So till now, the inlet valve and outlet valve, exhaust valve, both were closed. Now suddenly, when the exhaust valve is open at the end of the power stroke and at the beginning of the exhaust stroke, there's a sharp decrease in the pressure because it is going to be connected to the atmosphere. So thereby what is happening? There's an immediate drop down in the pressure. Okay, and as the piston moves from BDC to TDC, the volume is going to decrease. It is going to push out all these gases. So since the volume is going to decrease, it is going to go back to its initial state. So once this piston moves from BDC to TDC, it has reached the point A, that is the starting point once again, which is at the end of one cycle of the four-stroke diesel engine, right? So this is how the PV diagram is being written, right? So please remember this. The major difference between four-stroke petrol engine and four-stroke diesel engine is that first thing, in a petrol engine, air and fuel mixture will enter inlet, but in diesel engine, only air will be inlet during the suction stroke. The next major difference is that in a four-stroke petrol engine, spark plug will be there, but in a diesel engine, a fuel injector will be there. There is no spark plug in a four-stroke diesel engine, right? Okay. So now we shall go to the next one. That is how does the two-stroke petrol engine works? Let us see that. Okay. So let us see that. Yes. Okay. So the next thing that we have is a two-stroke petrol engine as per the syllabus. So we have seen till now about a four-stroke petrol engine and a four-stroke diesel engine. Now let's see about a two-stroke petrol engine, right? So the components present for a two-stroke petrol engine is same as that of a four-stroke petrol engine or diesel engine. So it is going to have a piston, a connecting rod, a crank, and a crankshaft, right? So the components are almost the same except a small change, okay? So what is that small change? I will show you here. So the small change is that first thing is that there are no inlet and outlet valves present for a two-stroke engine. Instead of that, it is called as ports because there is no separate element that is being drawn over here. There is no valve over here. It's like uh, there is no valve with a spring that is placed for the inlet and outlet ports present in a two-stroke engine. There is no valves at all. It is going to be only a port, only a pipeline where the opening and closing of this will be taken care by the movement of the piston itself. We'll see that. Okay. And the other thing is that there is a transfer port. There is another port that is coming into picture. So this is a transfer port. So this particular region is a transfer port. So there is one opening connecting from the combustion region and the crank region. So the crankcase and the combustion region, okay, were not previously connected, where there was no kind of opening or any kind of interaction to take place between the combustion region and crankcase region in a four-stroke engine. But in a two-stroke engine, there is an opening where something can be moved between these two regions. So that is going to be done, the movement is going to be done through the transfer port which is present over here. So this is a transfer port that we can see. So even this port, the working of this will be taken care whether it has to be open or closed, it is going to be taken care by the position of the piston, right? So it is going to be taken care by the position of the piston. So what is going to happen now? So just remember this point before I start the explanation. So in a two-stroke engine, for every stroke, for every movement, one movement of the piston inside the engine, two things will happen simultaneously. What are the two things? I will explain it during the working. So there are two things that is going to happen simultaneously. So what is the two things? Let us see now. Okay, right? So let us look at the working now. Okay. Yes. So let me go here. Just a moment. All right. Okay. So here, so let us start from once again where the piston is at TDC. Okay. Now, if you look at this, what is going to happen? So now look here, the piston has closed the exhaust port. So nothing can go outside the piston cylinder arrangement. But look here, the inlet port is open. The inlet port is open. So since this inlet port is open and the piston is moving towards the TDC, a suction has been created in the crank region, that is the crankcase, right? So when the piston is over here, okay, the outlet exhaust port is closed, the inlet port is open. So since the piston has moved from TDC to BDC, sorry, from BDC to TDC, okay, the suction has been created in the crankcase region. So air fuel mixture is going to be drawn in. That is what is shown in this arrow mark. So air fuel mixture is going to enter inside the crankcase region, right? So what is going to happen? So the air fuel mixture is not directly entering over here into the combustion region. It is going to enter into the crankcase region. So now next what has happened? Now once it has reached the TDC, okay, now the piston, let us assume the combustion is going to take place over here. So because of the combustion, the piston is going to move towards the crankcase. That is, the piston is going to move from TDC to BDC. We'll see that. So what is going to happen when the piston is going to move? So here you can see that as the piston is going to move towards the crankcase, that is from TDC to BDC, it is going to slowly close the inlet port also. Okay, it is going to close the inlet port. First thing. Second thing, what is going to happen? Now, since the piston is moving towards the crank end, there is compression going to take place in this because the volume that is good that was present previously and now has changed. The volume has decreased because the piston is moving downward, that is towards the crankcase. So because of this, what is going to happen? Because of this pressure, now all this air fuel mixture has no other goal to go through this transfer port. So all this gases that is present over here, air fuel mixture, since it has been compressed, the only way that it can go is through this transfer port because that is the only opening that is left out now. So that is the only path where it can move. So all this high pressure air fuel mixture is going to come over here and it is going to be placed over here, right? Now next, what is going to happen? We'll see. So now what is going to happen? So as the piston is going to, so now look here, as the piston moves downward, it is going to open the exhaust port, allowing the exhaust gases to go out, blocking the inlet of fuel, that is blocking the inlet port. So no more fuel can enter in. The fuel that was already present in the crankcase is now moving towards the transfer port. Now it is entering from the crankcase region to the combustion region. Now you can see this arrow mark where it is going to, all this air fuel mixture is going to come up into the combustion region, that is the above the piston, right? So that is what is going to happen when the piston is moving in a from TDC to BDC. right? So now just look here. Now till now only one stroke has happened. The piston has moved only from TDC to BDC. That's all. Only one stroke has taken place. But within that, inlet of fuel has taken place, and from the other end, already the fuel that was present in the combustion region, okay, has been that exhaust gases is going out. Two things are happening at the same time. Okay. Now with continuation with this. Now look here, the transfer port is now open, so air fuel mixture enters into the combustion region, right? Okay, so the next thing is that now now what is going to happen? Now only half a rotation has been done. Piston has moved only from TDC to BDC. Now when the piston is going to move from the second stroke, when the piston is going to move from BDC to TDC. Now when the piston is going to move from BDC to TDC, what is going to happen? It is going to stop the flow of air fuel mixture into the combustion region, first thing. Then as the piston moves much more higher towards the TDC, it is going to close the outlet port. That means all the exhaust gases should have been already gone, and it is going to open the inlet port. It is going to open the inlet port, right? Now what has happened? Now as the piston is moving towards the from BDC to TDC, what is the other two things? The other two things is that exhaust gases are being pushed out, okay, fresh fuel is being entered in, right? One side the exhaust gases is being pushed out, the other side fresh fuel has been entered in, right? Two things are happening at the same time once again, right? That is during the second stroke. Now as there is fresh fuel present and the piston is moving from TDC to BDC, what is going to happen? The air fuel mixture is compressed once again, and as the piston reaches the TDC, the spark, since it's a petrol engine, spark is going to be introduced and combustion is going to take place. So we'll see that. So as the piston is moving above, so till now it is open. Now as the piston is going to move above, we can see that it is first going to close the transfer port, and then it is going to open the inlet port. Okay, it is going to open the inlet port, and slowly it is going to close the exhaust port also. Now see, as the piston raises above, the transfer port is closed, the exhaust port is closed, but inlet port is open. That means during this time, air fuel mixture enters inside the crankcase once again. Exhaust port is closed, transfer port is also closed. Fresh fuel charge, air fuel mixture is present, which is going to be compressed. And when the spark has been introduced, it is going to undergo combustion, right? So this is all. So fresh air fuel mixture has entered in, combustion is going to take place, compression is also going to take place, right? And then power stroke is going to happen, and all the gases are also going to be let out. So all these four things, that is, fresh fuel has to enter, it has to be compressed, it has to undergo combustion, power, it has to receive the power, right, due because of the combustion, and this burnt gases have to be flown out. All these things, this complete thing is going to take place only with two strokes of the piston. The piston is going to move once from TDC to BDC, and the next time the second stroke from BDC to TDC. So within this two stroke only, the entire cycle is over. Right? So as it reaches the TDC, okay, as it reaches the TDC, a spark is being introduced through the spark plug. So here we have the air fuel mixture in highly compressed state. So because the spark is going to be introduced, the combustion is going to take place. Right? So that is what has been indicated in this uh, this is how a two-stroke engine works, right? So we'll continue in the next class. Okay.